All right, for this problem here, what we're going to do is we're going to simplify this radical, the square root of 45n to the fifth. And what I'm going to do here is I'm going to, for simplicity's sake, I'm going to kind of treat this like two separate problems here. I'm going to split up my normal numbers and my variables. And let's first address this simplifying the square root of 45. So if I list out my product, or rather my factors of 45, I have 1 and 45. I have 3 and 15. I have 5 and 9, and I think that's going to do it for me. So when I take a look at all of these factors, I want to find the perfect square factor in the mix here. So 9 is going to be my perfect square factor of 45. So what I'm going to do then is I'm going to rewrite the square root of 45 as the square root of 9 times 5. And let's take a look at these variables next, or this variable next. So I've got the square root of n to the fifth, and that can be broken into n to the fourth times n to the first. And remember, when you are trying to find your largest perfect square factor of a variable, you're going to take whatever the next, or the highest even number exponent is, less than the exponent that you're dealing with. So since I have n to the fifth, that's an odd number, so I'm going to set that extra off to the side, and what I have left would be n to the fourth afterwards. So what I'm going to do then is I'm going to write n to the fifth as the product of n to the fourth times n to the first. Now let's split up all of these radicals. So I have the square root of 9 times the square root of 5 times the square root of n to the fourth times the square root of n to the first. Now remember, all of this is multiplication, so I can rearrange any of these numbers in any order that I want. And that's going to be important in just a second here. I know the square root of 9, that is 3. I don't know the square root of 5, that's not a perfect square, so I'm going to leave that in the radical. This is going to be multiplied by the square root of n to the fourth, which is a perfect square. So this is going to become n squared. And I cannot find the square root of n, so I'm going to leave that inside the radical. And here's where the rearranging stuff works. I'm going to move this n squared over between the 3 and the root 5, which is totally legal to do. I can move multiplication around in any order that I want. So we're going to call this 3n squared. And then what I'm going to do is I'm going to combine my radicals into one expression. This is the square root of 5 times n. And if I lost you there, remember, the square root of 5 times the square root of n is equal to the square root of 5n, using that product property. So I just took this, and I took this, and I multiplied them together. My final answer here then is 3n squared times the square root of 5n.